Hello everyone and welcome to Hasian Education World channel. This tutorial is an introduction to regular expressions. Regular expressions are not specific to Python. They were used even before Python appeared, by Unix for text processing and then by other programming languages, text processors and text editors, and later in many different applications and tools. In fact, the idea of regular expressions first emerged in the early 1950s through Stephen Cole Kleene, the American mathematician who largely contributed to the formalization of the regular language, also known as rational language, which is expressed using regular expressions. Since the 1980s, different syntaxes or flavors are used for regular expressions. The syntax used by Python is similar to that used by Perl language. In my career, I've encountered and used irregular expressions even in some telecommunication network elements, such as GGSN used in 2G and 3G mobile network for internet access, in which one part of the configuration was done using regular expressions. Also in SMSC, SMS Center, and in different other service configurations. That's to say that the use of regular expressions is quite broad. So what are regular expressions? And what is their purpose? Regular expressions are a sequence of characters used to match a set of strings using search patterns. We will see these patterns in detail and how to use them in Python. Regular expressions, also called regexes, are very helpful in processing and editing text files, such as in text editors or word processors, and in search engines such as web or internet search engines. But in this tutorial series, we're going to focus more on the case where we search and extract specific sets of strings that we need from a text file using Python. We will see also the different methods available for us to use. For example, we have an output of some executed commands that is containing a lot of data. And we want to extract only some specific data that we need to analyze or to use in another part of our Python program, such as creating a report, for example, or generating another set of commands or scripts. In general, characters match themselves, and the regular expression will be the set of strings that we need in this case. But there is an exception regarding this point. Some characters do not match themselves. They are called metacharacters, and each one of them has a special meaning. These metacharacters can be used to match themselves as well, but in this case we have to precede them with a backslash in order for them to be considered as normal characters. There are also special sequences that are in the form of backslash followed by a ladder that are used to match different sets of characters. We will see all of these patterns in details now. So let's see examples of using the patterns for regular expressions and to understand them more. So in order to use regular expressions in Python, we need to import a module called RE. But please don't focus on this part for the time being. Just focus on this, which is the set of strings that we will use, and this part in which we will type in our regular expressions. Because we will see the other parts in details in the coming videos. Of course, you should focus also on this part, which will be the output. And that's all. Okay, I will give you a small description here for this small part of code. This is to import the RE module, which is the module for the regular expressions in Python. This is the data equals, this is just a string, and we will search and find words or strings inside this string data. And this is a variable which will store the result of the method findAll. This is a method we will see later together with other methods used in regular expressions module in Python. So don't worry for this method for the time being. And this method has two arguments. The first argument is the regular expression, which will be written between quotes or double quotes, and there is an R before. We'll see also why do we need to type R before this string later. There will be a video for compiling regular expressions, and I will explain these in details. So here we will put our regular expression, and the second argument is the string or set of strings which we are parsing or analyzing. In this case it's data, which is this one, data here. So this data variable is a string. It contains different words inside. So this is an example. This is a sample example. I don't want to use a very big file because it will not be helpful to our example. It will be not clear enough. So for example, we have different services numbers. Service 01, which has users, different users inside. Then we have service 02 and has other users. Service 03 and service 04. 4 services, each service has different users numbers. So let's start with the simplest pattern used in regular expressions. So we will start with the characters themselves. So let's start with service and run it, and this is the output printed. The output is the word service simply. This regular expression is the simplest, so each character will match itself in the set of strings. So S will match the S, E will match the E, and so on, and we will have the matching here. So here we have 4 matched strings, and we have, because we have 4 here. This is the simplest. If you want to have the exact service, we will type the exact service. Service 1, this will find this regular, this pattern will find it inside the data string and will return here the output 1, service 01. Okay, this is the simplest case. Now we will use the meta characters. The meta characters, as we have said before, are used to match a set of strings, and they have different meaning. So we will start to we'll see them one by one. Let's start with the first one, a dot. If you remember from the slide showing the meta characters, the dot matches any character except a new line. Let's run it to see, and you see that it matches every character in the string except a new line. Okay, even you see here it matches the letters, capital letters, empty spaces, digits. It matches any character in the string. Okay, this is a dot used alone. Let's see another one. What about if we add the caret before? Sorry, the caret before the dot. Okay, like this. The caret metacharacter has a different meaning. It matches the start of the string, so this one will match only the beginning of our string. Let's running to see the result, and here you find the output. This matched the first character in the beginning of our string, which is capital S. Another metacharacter is $. Can use it in this way. The metacharacter $, matches the end of the string. So this returns 8, which is the last character of our string and the ending of our string. We can use also a star. Let's type use, and then we add a star. So this pattern used in this regular expression should match capital U, small s, small e, and a star. We must know the meaning of the star. So star means it matches 0 or more repetitions of the preceding regular expression. So here it means that it will match 0 or more repetition of the E, of the preceding character, which is E. So this will match USE, even US it should match, because 0 or more, 0 repetition means no E at all. More, it means 1 E, 2 E's, 3 E's, and so on. This is the pattern expressed, represented by this regular expression. Let's type run to see. And you see here use US, because in this part here there is no E at all. There is a question mark instead. And there are some other parts where we have more than one E. This we have 2E, and we have 3E, and these are matched here also. So this regular expression matches all of these set of strings. We have also plus sign. Plus sign matches one or more repetitions of the preceding character. One or more. The star matches 0 or more. The plus sign matches 1 or more. So, for example, with the star we had this in the output, in which there is 0 repetition of E. There is no E at all. So using plus sign, we should have the same output, but without this US. Let's test it, and it's the case. We have no US. We should have at least one E, one or more repetition. There is also question mark, which is a little different. Let's see it here. Question mark means 0 or 1 repetitions of the preceding character. 0 or 1, no more. So we should not get these two. No 2E, no 3E, no more. Just 1 or 0. Let's run it. And you see here we have again this without E, 0, 1 E, but we don't have the ones with 2 E's or more. Okay, another meta character used in regexes is the backslash, and the backslash is a little special meta character because it is more important than in the others. It has more than one function. First, it is used to escape special characters, which will permit us to match characters like star, question mark, plus sign, and so on. So if we put a backslash before one of these special characters, they will be considered as normal characters. And they are also used in special sequences, which will be discussed just after metacharacters in this video. So if we use for example another regular expression, here we will use question mark and a dot. Now we are using a combination of two metacharacters in one regular expressions. In fact, when we combine more metacharacters in regular expressions, they will be more powerful. So in this case we have question mark and a dot. So this should match capital U, small s, question mark and a dot. Dot means any character. Question mark this way is a meta character. And okay, let's run it like this, and you see the result. But in fact, this is not the result we want. I want to match only parts of the strings which are in this pattern, US, question mark, and R. So in this case, this will not help. In fact, this is used as a special character, so it is considered as 0 or one repetition of S, which will contain also strings which doesn't have question mark at all, like these ones. I don't want this. So here I will use backslash, and you see the color has changed. Now it is not a special character anymore, it's a normal character which will be matched. So let's check this, and here this is the output we want. Another meta character is the brackets. The brackets are used to indicate a set of characters. Let's try it here. Open a bracket and we type in characters inside. So here, don't expect this regular expression to match the word user inside the string. No, it will match the set of characters inside this bracket. The set is composed of the character U, capital U, small s, E, and R. So this will match all of these characters. Let's run it and you see the result. All these characters, any characters of this set is matched and printed here. So we can add, for example, VO, and two other characters into our set of characters and run it again. You see we have now more letters. This V in service, and O doesn't exist, so it is not represented here. It is not printed. But if a hyphen is used inside this bracket, it can also represent a range. For example, 0-1. This represents any digit in the range from 0 to 1. Let's use it to match all our users. So user, this will match the character U, S, E, R, and then any digit in the range 0 to 1. So this is 0 or 1. I will add another range, and the digit after it should be in the range between 0 and 9. So what will be the result of this? This regular expression should give us user, should match, for example, this one, and then the first digit should be between 0 and 1. So this will not be matched. This will match 0 and 1. And the second digit will be from 0 to 9, for example 7. This will match. As a result, I will get a list of users from 0 to 19, because the first digit can only be 0 or 1, and the second digit can be any digit from 0 to 9. So the total will be 0 to 19. 20 will not be included, will not be matched, and more than any number more than 19 will not be matched. So let's run it. And you see here we have user 06, 07, 16, 17, 02, 03, 10. 42 not matched, 22, 34, 30, 26. All of these are not matched. So these brackets can be quite useful. We have also another metacharacter. It's a pipe, which is used between two regular expressions. It means the first regular expression or the second regular expression. So let's see an example. The first regular expression will be, for example, user and dot any character. Then we use pipe, and here we add another regular expression, for example service. So this will be regular expression A and this regular expression B, and this means pipe means regular expression A or regular expression B. So we run it, and we have as a result the first regular expression or the second regular expressions. All of them are here. There is also the curly braces, which specifies the number of copies of the previous regular expression which should be matched. For example, regular expression, if we put for example this regular expression and then 5 curly braces, this means that this will match 5 copies of the previous regular expression. 5 repeated 5 times, exactly 5 times, not 4, not 6. So maybe we will see this in another example, not this one. It can use 2 numbers as well, for example 4, 6. This means that this will match minimum 4 times for 4 copies these regular expressions, and a maximum of 6 times these regular expressions. And there is also the parenthesis, which matches any regular expression that is inside the parenthesis and indicates the start and the end of a group. We will see this pattern in another video about grouping. Let's see also some special sequences which we talked about in the introduction. We will not see all of them, but some of the most common. We have \d, which matches any Unicode decimal digit. For example, \d, we will use the same. Now we know the brackets 0 to 1, and we use \d, and that's all. You see, this is in different color. It means that it's a special sequence. So this will match user followed by a digit, either 0 or 1, and then followed by any Unicode decimal digit. We run our code and we see the result. We have these users with numbers from 0 to 19, and in fact this is equivalent. So backslash d equivalent to 0 to 9. Any digit. These are equivalent. There is also capital D. Capital D matches any character which is not a decimal digit. So it's more an opposite of the small d. Let's run it. And it's empty because we don't have such a case in our string here. We have only a user followed by 2 digits. To test it in a different way, let's remove all of these, and this should return all characters which are not digits. You see here, if we put a small d, it will return only digits. It will match only digits. There is also S, which matches a small white space, and the capital S, which will match any character which is not a white space. See here, or characters and digits. There is W, which matches a word character, which are most characters that can be part of a word in any language. I mean letters, as well as numbers and the underscore sign. Let's try it. You see it matches all the digits, letters. We don't have underscore here, but okay, let's add an underscore just to confirm. It will match it also. Here it is. And we have also the capital W. This will match any character which is not a word character. So the question mark, for example, will be matched in this case. So the question mark, the white space, all of these are not considered to be part of a word. So they are matched using the backslash big W special sequence. So that is the end of this video. I hope that you've enjoyed it. If it's the case, please like the video and subscribe to my channel if you're not yet subscribed, and hit the bell icon to receive notifications about the new videos in Hadian Education World channel. Thanks for watching, and see you in the next video of this series.